So now let's take a look at a few more functions. So let's say we have several functions. A is 9x squared. So this is and finally so we have these bunch of functions. Now I want to find the domain and range of each of these functions, right? So let's consider the very first function. Let's consider a, which is f of x is equal to 9x squared plus 4. Right, so now I want to find the domain and range of this specific function for now. So what should be the domain? What is the possible set of inputs that we can have for this function that corresponds to some output? So for what values of x is this function defined? Right, so we can see from the first expression, 9x squared, that x can be any value. We can take any value of x from the set of real numbers and we will still get some output, right? So our first expression is 9x squared, right? We can have any value of x. We can have x to be equal to 1 or -1 or some higher or some more negative numbers. And then we will still get some defined value which we will add 4 to it, and that will give us some corresponding output, right? So we can see since there are no restrictions on our value of x, then x can belong to the set of all real numbers. So that is our domain. But for our range, we see that from 9x squared, this term is always going to be non-negative, right? 9x squared will always be greater than or equal to 0. So it will always be non-negative. And you can see this because no matter what value of x we choose, because of our power, because of this power, which is an even number, this resulting value will always be non-negative. So if we take x to be equal to 0, we see that this is 0. If we take x to be equal to 1 or -1, we still see that 9 of 1 squared is equal to 9 of -1 squared, which is still 9. And that is also greater than or equal to 0. Similarly, if we take any other value of x, 9x squared will still be non-negative, right? This will always be non-negative. And then we end up, for our function, we add a +4. So the minimum value of our function, so the minimum value for this function is always going to be 4. That is the absolute minimum value of our function, right? And that minimum value occurs when x is equal to 0, right? So when we take f of 0, we have 0 plus 4, and that is equal to 4. We will never get an output that is less than 4. So we can see intuitively from the function that was given to us that f of x or y is equal to f of x will always be greater than or equal to 4. And that will be our range, right? Now, if you want to show this explicitly, we had 9x squared plus 4 as our function, right? So we can set y to be equal to f of x, and so we have 9x squared plus 4 is equal to y. Right, so now we can solve this equation for x. So solving this equation for x, we have 9x squared is equal to y minus 4, divide both sides by 9. And then we can take the square root on both sides. So x is equal to plus or minus square root of y minus 4 over 9. This becomes plus or minus square root of y minus 4. And the square root of 9 will be 3. right? So this will be our value of x. We have two expressions for x, one with a positive sign and one with a negative sign, right? Now we can see from the numerator that we have a square root term, and the argument of the square root, the argument is the term that is within the square root. This is y minus 4, right? And the argument is always going to be non-negative, right? Y minus 4 has to be always non-negative. Why does it have to be non-negative? Because if we take the square root of something that is negative, so if we take the square root of some negative number, then this will not give us a real number, right? So if I take the square root of minus 1, for example, then this will be equal to some complex number, something that has an imaginary unit. And this is not a real number anymore, right? And we only want to deal with real numbers since we have to deal with real valued functions, right? We're working with real valued functions. So the argument has to always be non-negative. And from this inequality, we can add 4 to both sides. And this gives us y to be greater than or equal to 4, right? Now, whenever we find an expression for x, when we try and attempt to find the range, it's always best to substitute this expression back into our function, right? So now we had f of x is equal to 9x squared plus 4. So let's substitute our value of x into the function. So we have two values of x, one with a positive sign, one with a negative sign. So let's take the one with the positive sign first. We have f of square root of y minus 4 over 3. Substitute this inside. So we have squared plus 4, right? So this becomes 9 times. So the square root term goes away, 9. So y minus 4 over 3 squared, which is 9, plus 4. The 9 cancels out. We have y minus 4 plus 4, and this is equal to y. Right, so we can see that f of x is equal to y, right? So our expression of x is correct, right? Since y is equal to f of x. Now, if we do the same thing for the negative sign, for our expression of x, we have f of minus square root of y minus 4 over y, over 3. This gives us, and you can see that since we're squaring this whole term, the negative sign goes away, right? So we end up with y again. Y is still equal to f of x, right? Now, it's best to do this because sometimes when we substitute our expression of x into the function, sometimes we get something like this, where we have f of x is equal to square root of y squared, right? And this can be only, so if we end up with something like this, then this term can only be equal to y when y is greater than or equal to 0, right? So we're taking the positive square root, so we should only get a number back that is non-negative. So we will discuss this more in a future example of a function. So, but whenever we try and find the range, we let y to be equal to f of x, and we solve the expression or the equation for y and see if there are any restrictions for y. So we found that y has to be greater than or equal to 4, and this will be our range. So y is greater than or equal to 4, or in interval notation, we can show that this is from 4 to positive infinity, right? We use this box bracket because 4 is included. Okay, so now let's consider one more function. We have f of x, and this is equal to 2x minus 3, right? This is our second function. So once again, very easily we see that this is a linear function, and there are no restrictions on x. X can be any value, and it will give us a corresponding output, right? So once again, very simply and directly, we see that x can be an element from the set of all real numbers, right? F of x is defined for any value of x, and similarly, you can intuitively see that since we can take any value of x, and since there are no square roots or anything, our output can also be the set of all real numbers. And once again, we can check this by letting y to be equal to f of x. So we have 2x minus 3. Solve this equation for x. So we have 2x is equal to y plus 3. Divide both sides by 2. So x is y plus 3 by 2. Now from this expression of x, we see that there are no restrictions on y, right? Y can be any value, right? We don't have any square root in the numerator or the denominator, and we don't have any variable in the denominator that has to be not equal to 0, right? So there are no restrictions on y, so y can be any value. Now, once again, we can substitute this value of x into our y, into our function. So we have f of x is equal to f of y plus 3 of 2 divided by 2. And this is equal to 2 times y plus 3 by 2. What was our function? So we have minus 3. Right, so we just substituted our expression of x into this function. So the 2 cancels out. We have y plus 3 minus 3, which is just y. So we see that y is equal to f of x. So once again, we have confirmed our range is the set of all real numbers.